Well, as we work through the rest of the month of November, a familiar friend or maybe foe is going to grab the weather headlines. It's the polar vortex. And as the northern hemisphere gets colder, that vortex above the North Pole will be getting stronger. And so to understand it, you have to think of the atmosphere like several stacked pancakes, our jet stream. Our jet stream sits, you see it here, about 5 to 10 miles over our heads. The polar vortex is even higher. It's roughly 10 to 30 miles. You could argue that it's always there. It just becomes more pronounced in the winter. And the shape of this vortex, it looks like a pancake. It's circular. When strong, the vortex rotates counterclockwise, but it's not always strong. And the stratosphere, where it sits, it's not always stable. The atmosphere is a fluid. We say that all the time. And I really like how climate.gov says it. Just like waves crash at the beach, atmospheric waves can crash too, both in the horizontal and the vertical directions. In our case of the polar vortex, warmer air can really disrupt things, the stratosphere, and it can cause winds around the polar vortex to weaken. Michael just alluded to that. Maybe even reverse. If this all sounds confusing, I get it. You could take a whole course on this in college, but look at the layers of our atmosphere. The pancakes analogy, that red line that you see, that's where we live. And it's important to note, I'll go back to that graphic, because temperatures cool as we go through the troposphere. That makes sense, right, as you head upstairs. But that second layer, the stratosphere, temperature is actually warm because that's where our ozone layer is. Ozone is real efficient at absorbing radiation from the sun. So let's stay in the stratosphere above where we live, but certainly part of our atmosphere. Let's say a big atmospheric wave crashes into the polar vortex. The vortex weakens because it's been disrupted. So that allows, as you see here, some of that cold air to move south. The shape of the polar vortex is no longer circular. It can, what you hear some people say, stretch or become wavy. And as it becomes a bit more wavy and more chaotic, lobes of Arctic air move across the northern hemisphere, and you see that orange blob? That's warm air. That displaces the cold air south. And there's a term that we use to describe this wild or wacky warm-up in the stratosphere. It's called a sudden stratospheric warming event, or SSWE. Temperatures may warm more than 50 degrees in just a few days. And remember, this is happening really high in the atmosphere, between 6 and 30, even 50 miles above the ground. The sudden stratospheric warming event disrupts our polar vortex. It sends cold air south. What's so cool is that forecasters can observe this warming with weather models. This model isn't one that you always see, too. It's a layer in our stratosphere. It's around 100,000 feet. On the left, today, that L is our polar vortex, and the reds are temperatures that are warmer than average. But look at the reds on the right. By November 26th, so this is in a few weeks, that's what a sudden stratospheric warming event looks like. Could it happen? Certainly possible. There are growing signs that it will. This graph shows there's general consensus for the stratospheric wind speeds to weaken. Michael showed us this as we head deeper into November, but there's a lot of disagreement beyond the end of the month. What could we possibly see? And I think, Britta, this whole process, when we look at the stratosphere warming and bringing cold temperatures to Earth, it's not a quick process, and it's very complicated. And so the polar vortex, which I know has become part of our
such a buzzword
vernacular, but it's very academic. I think it's important to recognize, though, we can track these signals, and that often leads to a change, maybe an impact.
Just like any sort of big synoptic, large-scale weather pattern, we look at all these clues, and that helps us piece together what can be happening as we move forward. I just, I think this is such a great conversation because I think people outside of the weather community, they just say, oh, they call it polar vortex because it gets really cold. Like we made up the word. No, it's an actual academic meteorological term that represents something really complicated. And that's what our jobs are. Take something that's really complicated and make it easy to understand.
Don't even get me started. This one graphic that our weather presentation team made is fascinating because it takes that week of December 5th. It's from the European model. We call it the Euro weeklies, and it's signaling that maybe some colder air could spill south due to the stratospheric warming. This isn't the stratosphere. This is the low levels
where we live.
The low level temperature departure. So you look what we could possibly see, and you could blame this on the weakening polar vortex. I do want to mention, Matthew Blue's been talking about it. It's rare to see a sudden stratospheric warming event in the month of November.
You think January for something like
Maybe
this.
February. And it can happen a couple of times in any given season. But to see something so early like this, and also for there to be marginally high confidence that
Yeah.
we might see something like this play out, it does lead to a bunch of questions. Will we get a storm?
Yes.
What's it going to look? Far
'Cause
too early.
if you have cold air and you have a storm, yes, we
Yeah.
get some snow. So we'll see. What I find most fascinating about the conversation is where do we go from here, right?
Yeah.
Because when we take a look at a seasonal forecast, and everybody wants to talk about how cold is this winter going to be? Well, when we take a look at that long range of a forecast,
Yeah.
we look at signals and where we could be going. So if this does pan out and the models showing this scenario playing out comes into fruition, it would give us a little nugget in the evidence part
100%.
of this conversation.
Yep.
That we very well could be in for a cold winter.
Yeah.
Because again, pattern recognition is a huge part of forecasting, and it's a huge part of weather. Weather repeats itself. So anytime that we have, an event that is unprecedented, yes, sometimes they truly are, but there might have been a weaker amount of that type of weather in history.
It's true. We'll see how things play out, but we have a long winter ahead of us. That's all I know.
I'm Team Snow.
Yeah, we'll see. Maybe we get it this year.
Maybe we get it.